Is the most recent revelation from NASA that the San Andreas Fault is starting to crack a portent of impending chaos? Is it possible that this breach could cause catastrophic flooding that would set new records? How well prepared are we for the possibility of complete destruction? Uncover the shocking reality that lies behind this terrifying forecast and join the battle against time. The San Andreas Fault is a monumental example of the unrelenting forces that are shaping the surface of the Earth. It denotes a significant tectonic junction, which is located where the massive North American plate and the formidable Pacific plate are interacting with one another in a never-ending dance. This fissure, which runs along the western coast of North America for roughly 900 miles, is a striking example of the dynamic character of our planet. The fault's motions have been responsible for some of the strongest earthquakes ever recorded in human history. This length alone does not explain the significance of the fault. It is just awe-inspiring. When the plates grind and slide past each other, they release a massive amount of stored energy in the form of an explosion, which in turn shakes the Earth and shapes the landscape. The San Andreas Fault, with its complex network of fractures and subsidiary faults, weaves a convoluted story about the evolution of geology and the resiliency of humans. The communities that are nestled around this geological marvel are living testaments to its capricious temperament. These communities have adapted their infrastructure and way of life in order to cope with the unpredictability of the landscape. Even researchers and scientists are intrigued by its mysterious nature, and they spend a lot of time analyzing every rumble and quake it produces in an effort to learn more about the inner workings of the planet. The San Andreas Fault is an indelible thread in the magnificent tapestry that is the geological history of our planet. It is a witness to the continuous motion that has changed our globe and will continue to shape it in the future. The fault's menacing presence continues ceaselessly, like a jagged scar slashing through the heart of California for more than 800 miles and connecting the remote shores of the Salton Sea to the craggy peninsula of Cape Mendocino. Its length is the longest in the world. It is a geological boundary that is independent of human construction. It imposes its will upon the land, splitting the state into two separate and turbulent worlds. The San Andreas Fault is a seismic monument that was meticulously fashioned over a period of eons by the enormous forces that nature possesses. Its unrelenting energy, which lays latent beneath the surface, coiled like a sleeping serpent, is an ever-present reminder of the unending transformation that the Earth undergoes. The fault travels across a wide variety of landscapes, from the dry basin of the Salton Sea, where dazzling mirages dance in the heat haze, to the wind-battered coastline of Cape Mendocino, where the Pacific's surging waves smash against unyielding cliffs. The Salton Sea is one of the driest places in the continental U.S. This geographical manifestation of the ever-changing character of the Earth carries with it an underlying sense of both peril and wonder. In spite of the fact that it powers the geothermal wonders of geysers and hot springs, it also poses a risk of rapid upheaval. This serves as a reminder that the Earth's restless core determines the fate of the surface above. In this area of opposites, the fault serves as a continual reminder of the power of nature and the precarious balance that exists between stable conditions and unstable ones. Active and passive earthquake faults weave a complicated web when they contact the tectonic plates of the Earth. The famous San Andreas Fault is a prominent example of this phenomenon. These geological wonders are important markers of the dynamic processes that sculpt the crust of our planet. Active faults are infamous for creating unexpected releases of stress, which can result in seismic occurrences that shake the ground beneath our feet. These faults are throbbing with energy that has been stored for a long time. The constant movement of these fissures is what causes the frequent tremors and the potential for devastating earthquakes. The San Andreas Fault is one of the most well-known of these faults because of its infamous reputation for being the source of large earthquakes along the western edge of the Pacific Plate that underlies North America. Passive faults, on the other hand, are characterized by a distinct lack of recent seismic activity, which results in an air of calmness. The once active fault lines in these locations have been rendered inactive as a result of past geological events, and the result is the presence of these dormant rifts. Although they are not active at the present time, passive faults are essential to our comprehension of the geological history of the Earth because they provide important information regarding the development of tectonic boundaries. The complex interaction that takes place between active and passive faults highlights the unending dance of tectonic plates, which shape landscapes and serves as a constant reminder to humans of the planet's ongoing evolution. It is extremely dangerous for the teeming urban areas of California, such as LA, San Francisco, and San Diego, to be located near the volatile tectonic boundary of the Pacific Ring of Fire. The continual geological dance that is taking place beneath the surface of the region is closely entwined with the region's stunning scenery as well as its colorful civilizations. The huge metropolis of Los Angeles, which is located between the Santa Monica Mountains and the San Gabriel Mountains, is bursting at the seams with creative vitality and glitz. However, despite its glittering exterior, it is extremely vulnerable because the San Andreas Fault is located nearby. The people who live in the metropolis have a subconscious awareness of the tremors that could, at some point in the future, completely transform their world. The city of San Francisco, which is located on the high landscape that surrounds the Bay Area, radiates an atmosphere that is equal parts innovative and artistic. The renowned Golden Gate Bridge acts as a sentinel above the San Andreas Fault, which is the location where the Pacific tectonic plate and the North American tectonic plate press against each other, resulting in both breathtaking panoramas and seismic instability. San Diego, located in the southernmost part of the state, is a tropical paradise along the coast. However, the proximity to the Rose Canyon Fault serves as a warning that even this picture-perfect refuge is not immune to the geological forces that have sculpted California's harsh beauty. This fact serves as a reminder that even this idyllic haven is not free from these forces. The people of these urban areas embrace the vitality of their surroundings while respecting the delicate balance that exists between human aspiration and the unforgiving forces of nature. This is why these urban centers continue to vibrate with life despite the persistent undercurrent of seismic stress that exists there. An elaborate dance, a never-ending ballet that has been orchestrated by the unstoppable forces of nature, has been performed by the restless plates that make up the Earth's lithospheric crust for millions of years. The seams at which these enormous plates meet, interact with one another, and occasionally collide are called fault lines, and they run all the way across the crust of the Earth. The ever-changing form of the fault is a direct result of the tectonic jigsaw puzzle that has existed for all time. The dramatic consequence of these plate movements is the occurrence of earthquakes, which are displays of raw geological strength that can inspire awe. Along the fault lines, tension and pressure are building up as the tectonic plates progressively slide past or beneath one another. It sounds similar to the creaking strain of a spring that is being firmly wound. Seismic energy is unleashed in a frenetic discharge when the accumulated forces are sufficient to overcome the friction that is holding the fault in place. In reaction to this geological symphony, the ground shakes, buildings swing, and the whole landscape itself trembles. Scientists and geologists, armed with an ever-growing understanding of the inner workings of the Earth, have meticulously plotted fault lines and observed their movements in order to better comprehend how the planet works. Their research reveals patterns, much like threads that are woven through the intricate fabric of time, that emphasize the ongoing activity of the fault. The fault's influence is evidence of the dynamic and ever-changing nature of the Earth, as seen in the powerful tremors that create mountain ranges, as well as the undetectable changes that are molding valleys. The journey of the fault is a story of perseverance and ceaseless change. It is an important chapter in the epic chronicle of the history of our planet. It is a tale that goes well beyond the existence of humans, one that is written in the rocky crust of the Earth, where the fault continues to perform its age-old duties as an architect of earthquakes, a sculptor of landscapes, and a continual reminder of the Earth's ongoing and unending alteration. In the field of earthquake monitoring and prediction, NASA's uninhabited aerial vehicle synthetic aperture radar has emerged as a game-changing instrument, offering a new technique for detecting and evaluating surface deformations. This has made UAV SAR a groundbreaking tool. With the help of this cutting-edge equipment, which is carried by an unmanned aerial vehicle, researchers now have an unprecedented capacity to monitor and grasp even the most minute changes occurring on the surface of the Earth. The UAV SAR system creates high-resolution photographs of terrain features by employing the synthetic aperture radar methodology. This methodology makes use of microwave waves to penetrate the surface of the Earth and generate images. Scientists are able to identify extremely minute changes in the landscape by regularly scanning specific places for them. These changes frequently precede or accompany seismic activity. These deformations could be markers of tectonic stress building or fault movement, and if so, they would provide essential insights into the mechanics of earthquakes. The adaptability of UAV SAR is seen as one of its primary strengths. It enables real-time monitoring during seismic events and the aftermath of those events, and it may be rapidly deployed to places that are prone to natural disasters. This makes it possible for those responding to emergencies to determine the scope of the damage and properly prioritize relief operations. The data collected by UAV SAR helps in the process of developing and improving models that are used to forecast earthquakes. Researchers can improve their grasp of seismic behavior and strengthen predictive algorithms by evaluating long-term deformation trends and connecting them with geological data. This helps the researchers gain a better understanding of seismic activity. Even though accurate earthquake prediction is still difficult to achieve, UAV SAR has made tremendous strides in improving our ability to foresee and lessen the effects of natural disasters such as earthquakes. UAV SAR is a unique technology developed by NASA that detects and tracks surface deformations with an accuracy that has never been seen before. This has fundamentally changed the way earthquake research is conducted. The incorporation of this technology into seismic monitoring systems has the potential to save lives, reduce the amount of damage caused, and increase our understanding of the complex processes that shape our world. The foreboding presence of the possibility of a big earthquake, also referred to as the Big One, hovered menacingly over the region, throwing a shadow of uncertainty over it. In recent decades, the symptoms have grown increasingly evident as the restive tectonic plates of the Earth exhibited increased seismic activity, sending tremors through the hearts of people who resided in close proximity to the epicenter. Scientists and seismologists diligently studied the shifting landscape, with their instruments registering the unmistakable rumbles that hinted at the enormous forces that were brewing underneath them. The ground itself appeared to moan, and inhabitants reported feeling uneasy as a result of slight but apparent disturbances in the ground. The structure's reports of creaking and ever so slightly wobbling served as a jarring reminder of the precarious equilibrium they occupied. Not only did rumblings occur deep under the Earth's crust, but the surface of the planet also witnessed subtle changes that were not visible to the naked eye, but were incontrovertible when subjected to the scrutiny of scientific study. Fault lines that had been quiescent for a considerable amount of time revealed tiny changes in their geometry, which provided a hint at the enormous pressures that were developing beneath the crust. The inhabitants of the areas that were impacted lived in a state of wariness because they were acutely aware of the impending danger. Preparedness efforts were already underway, and authorities were making an effort to provide locals with the information and tools they needed to lessen the impact of any potential destruction. In preparation for the anticipated upheaval, painstakingly detailed evacuation plans were drafted, and an adequate supply of emergency supplies was accumulated. There was a real sensation that time was both a friend and a foe at the same moment as everyone in the region held their collective breath. The lack of knowledge was unsettling, but the enhanced vigilance and preparation generated a glimmer of optimism that, when the Earth at long last unleashed the stored-up energy it had been harboring, the reaction would be one of resiliency, strength, and solidarity in the face of hardship. The possibility of the Big One served as a jarring reminder of the incredible power that nature possesses, prompting mankind to recognize its own fragility while simultaneously working to maximize its own capacity for resilience. Thanks for watching. For more, subscribe to our channel.